Bouncing balls. What happens when you drop a ball onto a hard, flat surface? It starts with potential energy. It bounces up and down until it finally comes to a rest. Where did the energy go? You will be investigating the following question. How do balls differ in their bouncing behavior? Here are the materials you will need for this activity. 1. Tennis ball. 2. Rubber ball. 3. Balance. 4. Meter stick. 5. Masking tape. 6. Cardboard box or shoe box. And 7. Your science journal. The goals of this activity are 1. Identify the energy forms observed in a bouncing ball. And 2. Infer why the ball stops bouncing. For your safety, please wear your goggles during this activity. For this activity, follow these procedures. 1. Measure the mass of the 2 balls. 2. Have a friend drop 1 ball from 1 meter. Measure how high the ball bounced. Repeat this 2 more times so that you can calculate an average bounce height. Record your values on the data table like the one in your textbook. 3. Repeat step 2 for the other ball. And 4. Predict whether the balls would bounce higher or lower if they were dropped onto the cardboard box. Design an experiment to measure how high the balls would bounce off the surface of a cardboard box. In your science journal, write your conclusions. 1. Calculate the gravitational potential energy of each ball before dropping them. 2. As the balls fall, what happens to their gravitational potential energy and their kinetic energy? What happens to their kinetic energy when they hit the floor? 3. Calculate the average bounce height for the 3 trials under each condition. Describe your observations. 4. How did the bounce heights compare when dropped on a cardboard box instead of the floor? Why? Hint: did you observe any movement of the box when the balls bounced? And 5. Use elastic potential energy to explain why the balls bounce to different heights. The expected outcomes for this activity may be 1. To calculate the gravitational potential energy of each ball before dropping them, use the formula GPE equals m in kilograms times 9.8 meters per second squared times height in meters. 2. As the balls fall, GPE decreases. Kinetic energy increases. Most of their kinetic energy is converted to elastic potential energy. 3. To calculate the average bounce height, use this formula. Average height equals sum of heights divided by number of trials. Answers will vary. 4. The balls don't bounce as high on the box. Some of the kinetic energy the ball has when it hits the box is transferred to the box, causing the box to vibrate. This energy is then unavailable to help propel the ball up. And 5. When a ball hits the ground, most of its kinetic energy is converted to elastic potential energy. This becomes kinetic energy as the ball rebounds. Some balls store more elastic potential energy than others.
And if I haven't made it clear in class yet, or maybe I have and maybe you just weren't here, you will be doing calculations. And at this point, if this is second semester, everybody should be on the same level math-wise for the problems that we will be doing for the rest of the school year. If you are having some serious issues with some of the calculations and algebraic equations, you need to talk to your math teacher, because I'm sure that they have a particular way that they would like you to fill out your equations and use them. So if there's any problem with that, double check with your math teacher. So section 2 of chapter 4, describing energy. Your essential questions are, what is the difference between kinetic and potential energy? How can you calculate kinetic energy? What are some different forms of potential energy? And how can you calculate gravitational potential energy? When something is able to change its surroundings or itself, it has energy. Energy is the ability to cause change. Without it, nothing would ever change. The moving tennis racket in the figure below has energy. The racket causes change when it deforms the tennis ball and changes the tennis ball's motion. Turn on an electric light and a dark room becomes bright. Turn on a portable music player and sound comes through your headphones.
But you know, happiness can be found even in the darkest of times. One only remembers to turn on the light.
In both situations, a change occurs. These changes differ from each other and the tennis racket hitting the tennis ball on the previous screen. This is because energy has many different forms, and these forms include mechanical, electrical, chemical, and radiant energy.
Look at this man juggling oranges. If you consider the system to be only one orange, then it has several external forces acting on it. The force of the juggler's hand does work, giving the orange its original kinetic energy. After the orange leaves the juggler's hand, only the force of gravity acts on it. Let h represent the orange's height measured from the juggler's hand. On the way up, its displacement is upward, but the force on the orange, Fg, is downward, so the work done by gravity is negative. On the way back down, the force and displacement are in the same direction, so the work done by gravity is positive. Thus, while the orange is moving upward, gravity does negative work, slowing the orange to a stop. On the way back down, gravity does positive work, increasing the orange's speed, and thereby increasing its kinetic energy. The orange recovers all of the kinetic energy it originally had when it returns to the height at which it left the juggler's hand. It is as if the orange's kinetic energy is stored in another form as the ball rises, and is transformed back to kinetic energy as the ball falls. Now consider the system to be the orange plus Earth. The gravitational attraction between the orange and Earth is a force that always does work on the orange as it moves. If the orange moves away from Earth, energy is stored in the system as a result of the gravitational force between the orange and Earth. This stored energy is called gravitational potential energy and is represented by the symbol PE. The height to which the orange has risen is determined by using a reference level, the position where PE is defined to be 0. The gravitational potential energy of an object is equal to the product of its mass, the acceleration due to gravity, and the distance from the reference level.